Hello friends, today's project is land detection system along with LIDAR mapping. This project is the extension of the project ADAS system and anti-collision system using LIDAR for EVs and autonomous vehicles, which was covered in the last section. Kindly click on the link below to check part 1. In this project, we will implement an ADAS system for land detection. This system will help you to keep your automatic vehicle in the driving lane. In the last section, we used Raspberry Pi and LIDAR to create an anti-collision system. Here, we will add a camera to track lanes and keep our vehicle in its lane. We will use image processing for land detection. For this project, we have used an NVIDIA board in place of a Raspberry Pi board for testing. You can also use a Raspberry Pi board if you are making a college level project. But for actual deployment, we need a better board. Hence, we are using the NVIDIA board. Let us see the circuit. We have connected a LIDAR and a USB camera to our board. You can use any LIDAR and camera. Let us see the demonstration first. We will use a road video for testing since this is a prototype. The camera is scanning the road and LIDAR is plotting the surroundings and providing distance and speed cameras to detect the lane and keeping the vehicle in its lane. If the vehicle changes lane, the system will detect the lane and keep the vehicle along with it. I have discussed how to use a LIDAR in the previous session. Since the LIDAR is working on a serial port, we have to install a serial library in the NVIDIA board. Install the LIDAR library in the NVIDIA board and use it easily. This is the code for the anti-collision system which we have covered in the previous session. For making a land detection system, we will use the OpenCV library. Install the library on your board. This is the code for our project. First, import OpenCV library for image processing and NumPy library for processing. After this, we have to capture video from the camera. This command will capture video from the USB camera. Inside the infinite loop, we will resize the frames into smaller frames for processing. This is all image processing code to detect the white line and yellow line on the LAN. This piece of code will mark the detected LAN. This is to show the image frame in real time. Now we are done with the code. We will run the code. Now you can see a system is detecting the LAN. These two are different codes. One is for anti-collision system we covered in the previous session and one is for LAN detection. Now how to combine these codes? For combining these, we will sub-process. In sub-processing, the board will start both the script at the same time to create a complete ADAS system. For sub-processing, we have to create a Python code in the same folder. These two lines of code will run all the required codes at the same time. Now open the terminal and run the sub-processing code. You can see LIDAR is giving an alert if someone is about to collide with the vehicle. At the same time, the camera is recording video and detecting the LAN. This project is published on electronics4u.com in 2 parts. This is the second session. We will expand this project in our next session and add more capabilities to our ADAS system. This is all about this project. We hope you liked it. Do implement this project at home and let us know your experience. Thank you.